Tutorial sheet 3 question 5 is, well, the first part of it is mainly about revising a bit of bookwork about a varactor-diode frequency modulator. So what we have is essentially a circuit which has some inductance associated with it, and in parallel to that we have some variable capacitance, which is due to our varactor diode. And so what we're essentially saying when we're using these varactor diodes is that we have some capacitance associated with this diode, which is we can denote as C, and because we can vary this, let's say we can have some plus or minus delta C associated with it. So C might be somewhere in the middle of its capacitance range, and we can either go above or below that capacitance. So because this is a resonant frequency, a resonant circuit, we're going to get a resonant frequency associated with this circuit, and that's resonant frequency is given by the usual equation, which is just 1 over 2 pi root LC. So when we're at our nominal capacitance, so we've got no deviation, this is our center frequency, and this would be the situation if you had no modulation, so this would just be our carrier frequency, FC in this case. And if we were to add on some capacitance, so now we go to a stage where we have positive delta C. Well, as we add on capacitance, because the C is at the bottom, we're going to have a lower resonant frequency. So now we're going to have a second situation where we're going to have F minus delta F is equal to 2 pi square root of L into C plus delta C. And what we can do is we can take these two equations and divide one by the other to give us something that looks like F minus delta F over F is equal to 1 plus delta C over C to the power minus a half, just by rearranging and dividing these two equations. Now if we assume that delta C over C is very much less than 1, we can use the binomial expansion. If we use that, then we get a situation where we can represent and approximate delta F over F as approximately equal to a half delta C over C. But that can only be the case if we assume that this is correct. So if we use that, then we can obviously write that delta C is approximately equal to 2 delta F over F multiplied by our capacitance that we have on our diode. Now we're given in the question that delta F is equal to 80 kilohertz. Our center frequency F is 100 megahertz, and our capacitance, our central capacitance, is equal to 75 picofarads. So placing these three elements into that equation, we get delta C is equal to 0.12 picofarads, which is the answer that we want.